Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode 2360, longest cycle in a graph. So we're basically given a graph where we're guaranteed that each node has at most one outgoing edge. So we cannot have a node with more than one outgoing edge. It's either it will have one edge or zero edges. And basically we need to find the length of the longest cycle in this graph, right? And a cycle is something that starts at a node and then goes back to it. So what will be our intuition and approach to solve this problem? The key insight here is that each node can only be part of one cycle, right? Because there's only one outgoing edge. So if there is a cycle, it's going to be on the path of that edge. Otherwise, there won't be a cycle, right? And so since there's only one outgoing edge, there can't be any other edge that leads to a cycle. So that's one key insight. And so then our initial approach then is like, okay, just check each node if there's a cycle and record the length and then keep track of that and get the max. But then when you do that, for example, if you start at 1, or let's say we start at 0, we go down this path and we find, oh, there's a cycle here. Next, when we go to 1, we'll again be going down this path, right? Because we'll find the same cycle. So then the next question is, how do we avoid redundant work? So to avoid redundant work, all we need to do is keep track of the nodes we've already visited. So that way, from here, when we hit something we already visited, we know that we must have already calculated the cycle of that path. And so all we do is just break out and say, okay, we don't care about this anymore because, there's only the cycle that existed here was already accounted for, and there can't be any other cycles because, remember the first assumption, each node can only be part of one cycle. So that's that. Now the next question is, how do you keep track of the length of the cycle, right? Because if you start from here, you'll go here and then down this path. We went through 4 nodes, but the cycle's length is only 3, right? It's 1, 2, 3. And, imagine we could have like 10 different nodes here before we hit the cycle. So how do we know the length of the cycle? Because it won't just be the number of nodes we traveled. So to keep track of that, every time we kind of embark on a path to find if there's a cycle, we'll keep track of the node. For example, if we started from 0 and the steps, right? So node 0, 0 steps. Node 3, 1 step. Node 2, 2 steps. Node 4, 3 steps. And then when we go back to node 3, we'll say, hey, this is 4 steps, but then we already saw 3 at step number 1, right? Because we were keeping track of that. So then all we can do is 4 minus 1. That would be 3. So then we know the cycle length is 3. So we'll basically keep track of the node and the step number that we saw it at. And that way we can compute the cycle. So that was, our overall approach. Let's go ahead and write the code and see what that looks like. So first, what we need to do, initialize our max cycles, right? So we'll initialize that to -1 and we'll return that at the end. So if there are no cycles found, it'll just be -1. If we find something greater than that, we'll replace it. And at the end, we'll return max cycles. The other thing we need is our set of visited nodes, right? So we can say set integer visited, or what we can do is just use an array. So we can say int visited equals new int edges.length, right? So we can just say in this case that 0 is not visited and 1 is visited. So that's that. And now let's just go through each node. Remember, we're trying to start from each node and determine if there's a cycle. So we'll say from 0 to edges.length. The first condition is if we've already visited this node, right? Or there's no edge going out from this node, right? Which means edges at I is -1. That means, there is no edge, right? So in this case, we'll just continue, right? Because, there's nothing to explore. So then what we'll do is we'll try to compute the cycle starting at this node, right? So we'll say longest cycle, we'll need the I, which is where we start. We'll need the edges to traverse the path. And remember we said we need to keep track of our steps, right? So we'll pass in the step number, which is initially 0. And we'll pass in a map of integer to integer, which will be basically the node to step number, right? So this is what we'll use to see, okay, what step did we see the node, so we can know how long the cycle is. So this will be our recursive function, and over here we'll just say if cycle is greater than max cycles, and this is maybe just better as max cycle, we'll return, or no, we'll set max cycle equal to cycle, and at the end we'll return max cycle, right? So this will be the top level function. And next what we'll do is compute this longest cycle function. So we'll say private int longest cycle, and I'll just write out the signature here. So I've written the signature here, and I realized this is not correct, so we should pass in a new hashmap here for the node to step, and this is actually the type over here. So now that we're in this function, we'll take care of some base cases. So again, if we hit an edge or a node that has no edge outgoing, then we'll just return -1, meaning we know that there's no more edge past this point, there can't be a cycle anymore. The next thing we'll check is if we've come back to a step that we've visited in this round, right? So we'll say if node to step dot contains key I, that means if this I is something that we've just come back to from this round, right? Then what we'll say is we'll compute our cycle length, which will be the current step, right? So in this case, remember the 3 we returned to 3 at step number 4, minus node to step dot get node, right? So or dot get I. So in this case, we'll see that, oh, we've already saw 3 at step number 1, and now we're at step number 4, and we're seeing, step number 4, and we're seeing that 3 again. So we'll return 4 minus 1, which is 3. The next thing we need to do is, if we've reached I as something we've already visited before. So imagine when we traverse from 0 to 3 to 4, 3, and then when we start traversing from 1, we'll notice we reach 3, but 3 is something that we've already seen before in our visited. So we just need to, just stop because we've already visited the cycle last time, right? So actually another thing we'll also need here is our, visited set. So let me just pass that in over here. And what we'll do here is if visited dot contains I, then we'll just return -1 because we're not finding anything new, so we just say -1 because if we've already visited it, we've already counted that last time, right? And so now once all of these base cases are passed, what we'll do is we'll add the node to our visited list, and we'll also add it to our map with the current step number. So we'll say I and step, and then we'll traverse the longest cycle in the next edge. So we'll say edges at I, which is the next node. We'll pass in the same edges. This time the step will be step plus 1 since we're taking one more step, and then visited, and the map will remain as is, right? And that's what we'll end up returning. So hopefully this does it. Let's run this code and see how this does. All right, this is edges. Okay, I remember we used an array for our visiteds, and I used a set here, so I'll just fix that to an array, and then over here we'll just say if visited at I is equal to 1, and over here we'll say visited at I is equal to 1. All right, and we change this to cycle instead of cycles. All right, accepted. Let's submit. Perfect. Thank you so much for watching. I'll see you in the next video. Cheers.